You guys ready?
No.
And we're live! Alright, welcome to Mr. Max class. This is 6th hour, the last of the geometry classes for the day. Today we are counting dots, and I know, they're intimidating, right? But the good news is that they're just as scared of you as you are of them. Now, how did you count them? Somebody come up here and show us how you did it. Haley, here you go. With the hands. Wonderful, and we are live, yes? Just a little delay. Okay, Haley, you're going to be on TV, sorry. Are you cool with that?
Okay.
All right.
How do you want me to do this?
However you want to do it.
Okay.
Disseminate your information.
And you ate them.
Gotta stay hydrated.
2, 4,
Did I just hear cracking out though?
6, 8, 10, 12,
Wow.
You can count?
14. What?
Yes.
You want
Can I have
to say
these?
something to me?
All right, let's go. So, what she did was this: 1, 2, and then 3.
That's the amount of minutes I've seen my dad.
Oh, she just did circle.
Oh, me Padre.
Like this?
She did it like 4, 6, 8,
7 by 2s.
Wait, those are circles? So you did it in real time?
No, I just marked them. She marked them. So 2, 4, 6.
Where do I start? Let's play follow the leader. So where do I start?
Okay, 2.
Start here,
Yes.
and then where do I go?
Okay, and then you go to bottom
Why
one.
didn't
Down,
you go
all the way
back
down?
and do it again?
Yes. 2, 4. No, other way. Other side. Other circle.
Nino
And then-
comprendo.
All the way across?
Yeah, the 2.
Horizontally?
Yeah. Plus you.
I sneeze like Dennis Weston, bro. Hey, they go up and do it for me.
And then what? Wait, come on. Use lines here. Sorry, I should have been more specific. I didn't think you could do that. Just put it back in.
Oh shit, right.
Right?
Okay, so 2, 6,
He said lines, Haley.
sorry, 8,
Oh my god. Full circles are voluptuous.
Whoa.
All right, more or less, I think this is what she did. So direction matters. So watch. Here's the idea. She started here with these guys, right?
Yeah.
And then she started going like this. Something like that. Something like that. Something like that. Okay? That's pretty cool. So we have 4 plus the spiral. Now, if you notice, the outside spiral has how many dots? 4. And then the inside spiral has how many dots? 4. So what we did here is 4 on the corners. Then we did 4 in an outward spiral, 4 in an inward spiral, right? And then we had 3 on the inside, I should say.
I
Right?
came up with a really creative one. but-
Really? We'll have to find out. All right, who's next? Laura Lee.
I don't know.
Yeah, you did.
You want to ask me?
Leaving yourself.
bed.
Again, if you come up here, you're consenting to being on YouTube, which you totally can do as a
no.
mic. Totally.
Oh wait, I don't
Shoot.
have.
Can I flash the camera?
do you want me to like write the
no.
numbers? Or
Either show us the path or the numbers. Make the numbers like big.
Okay, so like,
So follow her path. So she's doing that. Okay. Interesting.
oh yeah.
Oh, I see what's going on. I see what's going on. A smaller step in. All right, so check it out. Nice. Thank you very much. So here's the idea. She did top row. Bottom row. Is it what you did next? No. Where's the 4?
Outsides.
No.
She did the outsides first.
No.
She did what she did on the top.
Is that a 5?
No, it's one. Okay.
No. Here, 5. There's a 5.
Oh, and right next to 10.
Don't worry
Right
about it.
underneath 1 is.
Oh, there's the 4. So she
No,
did.
it's not the 4.
Where's the 4?
Why?
Right under the 1. Under the 1.
That is
That's a
not
4?
dude.
That's a 4.
Okay, now I see it.
I'm gonna look back.
No way.
She did these 3.
Yeah, and then I do the bottom.
And then the bottom. Okay, so that's what it was. Check it out. So what she did was 3 plus 3 plus 3. And then she kind of did this thing. So 2, 2, and then these individually. So we had 3 plus 3 plus 3 plus 2 plus 2 plus 1 plus 1. Nice. All right. Yeah. Go.
Go.
No, I actually bought this.
Gotcha. All right, so check this out. This is cool. I'm going to go a little bit further and say that she made a T here. So check it out. We have symmetry. Right? We get 5 here for free, 5 down the middle, and 5 on the side. 5, 5, and 5 is 15. Another clever way you could have done it and said, look, I don't even need to count this side because I get it by symmetry, right? I get 5 here, 5 for free on the other side. Don't have to count them. And then 5 down the middle. Well done. So far, that's the most efficient method. Any others? Any other interesting ones?
I got you.
Yeah, what? Andre.
No.
Go.
Right, write the numbers.
Do numbers or lines, I don't care.
1.
I'm a big fan of the lines, but you guys seem to like the numbers.
Yeah, okay, I did that.
Like the whole point is to not have to count all of them individually, but we put numbers down, we end up doing it. Go ahead.
Okay.
So you did the four corners.
Yeah, then you do that and you do that, which this is 7, this is 5, and then you have to subtract that because you do it so.
Yeah, so check it out. So here's what Andre did, right? Nice. Thank you very much. Excellent. Yeah, this is one of my favorites. So he did the four corners. Everybody seems to like the four corners. And then he did 5 and 7, but he noticed an overlap. So check it out. Whenever those lines cross, that's why I like doing the lines, right? When those lines cross, we have a point of intersection, which means we counted something twice. Whenever a line crosses, we counted it twice. So we have to subtract one of them, right? We want to count it one time but not the other. So what he did was 4, like he did down here. 4 plus 5 plus 7 minus 1, that's going to get you 15. Well done. Any others?
I got you.
Sloffer, go.
Yeah.
No naughty symbols.
Let's go.
Hidden Chuck E. Cheese. So I seen there were 3 right here. You see?
Yeah,
I
I see
see there
him.
were 3 right here.
Look at the other 3 on the side for free.
And I pretended there was 3 right here. You know what I mean? And then I added it all up. I don't remember what my equation was.
That's
It
my
was
boy,
like
right here.
3
Well done.
plus 3 plus. I don't know. It was like 3.
I got you.
Minus
Check it out. This is
5.
brilliant, okay? Because I've had to show this to everybody else all day, and this is a different way of doing it that I haven't thought of. But it's the same concept. So check this out. So he's saying, look, there are invisible dots here. Invisible dots. So we've got 3 and 3. 3, 3, 3, 3, and 3. How many 3s do I have here? Well, I've got 5 in the middle and 2 on the side, so I've got 7 3s. That's 21, right? So 21 3s, plus these guys. So that gets us 23. Now, how many dots do we do too many? 1, 2, 3, 4, 5, 6, 7, 8. Subtract 8 from 23, what do you get?
15.
Maybe.
Self-development.
It's very cool. Well done. I had a student last year that showed this to me. It was a different one, but it was similar to this. His name is Alfredo. Shout out to Alfredo because we are live. Hey, Alfredo. This kid, brilliant. I never thought about this. And well done, Schloffer. You're the second one to ever do it other than myself. This is how I do it. And it requires way less counting. I think it's pretty efficient. So check it out. This is 7 across here, right? Which means this should have 7 in the top row. And we also know that this is 5 up and down, which means this should have 5 in the top column or the left column. So if I filled all these dots in, how many dots would I have?
28.
Try again. 5 times 7? 35. It's all good. It's all good. You were doing 7 times 4. It's okay. 5 times 7. It's the right answer, just wrong question. 5 times 7 would get us all the dots, right? Now, that's 35. So the whole dumb thing is 35. Now, what do I subtract? Well, I know that I've got 1, 2, 3, 4, 5 here. And I have 4 similar shapes here and here. So I have to do very little counting. I subtract 5 4 times. What's 5 times 4?
20.
So it's 35 minus 20, which gets us 15.
Honestly, I think it's just easier to count.
Individually? Good Lord, no. Right? All I had to do is do 5 and 7 makes 35. I subtract 5 4 times. So, boom, 15. The negative space can be a lot easier. Or you just count it. Yeah, I mean, you can do anything you want. There's no wrong answer. There's just more interesting answers. What's going to be useful is that when you look at something like this, right, which is very simple. It's just a number, right? That's all it is. It's 15. It's very boring to think of it in multiple different ways because 15 gets the job done. But when you have variables and you have exponents and all kinds of other stuff, it's good to think about what it means in different ways you can arrange it, right? So when you see an equation, you might be able to realize what it means. So check this out. If I were to write this,
Give me a minute.
What?
right? Shh, Flopper, turn around. So if I were to write this, okay, 5 times 7 minus 5 times 4, nothing special, right? But that's what that is. And to see those connections and to think of numbers like that, now that's interesting. Again, the idea being that if I were to write 5 times 7 and subtract 5 times 4, this board sucks. It's a 5, not a 8. I'm sorry, Autumn. All right, so we've got this, right? To think of that as this, now that's powerful and that's useful. Because we're going to get some things that aren't just dots on the board on here, right? Especially when you get up to higher levels of mathematics. Knowing what it means. What does this mean? What does this equation mean? And being able to think about it in multiple ways is useful. That's mathematics. Okay. All right? You want to see some other interesting ones? Follow me on IG. I'll post them. Okay?
IG.
On the IG.
I thought you meant how to craft an iron golem.
Bruh. All you need is 4 iron blocks and a pumpkin.
Alright, he definitely bought the money.
Nerds! All right, so let's move on. Next thing we're gonna do, I'm gonna try and position the camera without losing it. The cord is very, very sensitive, so we're gonna have to proceed with caution. What I want you to do is get out that homework that you totally looked at. Here we are.
Yeah.
Okay, if the stream goes dead, I'll have it back on.
Oh. Like, literally,
Like, get him out of there.
9. Never mind. Just wouldn't be funny if
Also, when you said knock him down.
Yeah, if he says knock him down, have fun.
Okay.
No, you don't. It's
The stream should be back on soon. Yes,
oh, it is okay.
that's true. That's
The
true.
homework that you didn't
Yep,
help him with?
yep, that's true.
I came here.
All right. Yep, didn't help. Refused to.
No, you didn't refuse to. You were helping. You were talking to Danny and Tucker and Zed.
I was helping them? All right, so here we are. So, what I need you to do is take a look at number 4. We've already done 1 and 2 together. We have done 3. Confirm or deny?
Just deny.
Wonderful. 4, if you were here yesterday. So number 4 says 1 and 2 are supplementary. Okay, that's what they've given us. That's what we're starting out with. Let me adjust this just a smidgen. All right, there we go. What we're going to do is write this stuff down. And we don't know what we're doing because we're new at this. And I'm not a real math teacher. I just make it up as I go along. So what I'm going to do is write down what I know. And the goal is, again, to get 2 and 3 in the same room, right? We talked about that yesterday, right? We want to ultimately prove that they're congruent, that they're the same dumb thing, right? That they belong together. But as long as we get them in the same room, the math will work the rest of the magic, right? Just get them in the same room and the math will take care of the rest. Aww, okay? So we need to get them in the same equation. Now you'll notice the things that we have are this. 1 and 2 are supplementary. So they're related somehow, right? We can talk about what that means in a second. But we know 1 and 2 are related, right? So not 2 and 3, but 1 and 2 have a connection, right? Over here, I repeated the same thing, which is why I told you to cross it out and write this. Angle 1 is congruent to angle 4, right? So we know something about 1 and 4 being connected. Again, not 2 and 3. And then we get 3 and 4 being connected. Again, not 2 and 3, right? We got 3 and 4. So we have connections here. The question is, how are we going to bring them together? What do they have in common that's going to allow us to put them in the same room together, right? How are these people going to meet? What's our meet cute? So let's write down what we know. Before we do that, let's assign some colors just for funsies. Angle 1, what color do you want to use?
Purple.
Purple it is. All right, angle 1 is purple. What about angle 2?
Green.
Blue it is. Angle 2 is blue. 2 blue. 2 blue. All right, what else we got? How about angle 4?
Green.
Green it is. Angle 4 is green. So wherever I see 4, it's going to be green. Oh, yeah, by the way, I should probably do this too, right? Angle 2, angle 1, and then angle 3. Can't use red. I always use red for swag box. Magenta it is. I don't really have a good magenta, but I do have pink. Yeah, go. So 3. Pink. Hey, enough. No more. We're done with that.
Yeah, no need to be a scumbag.
You understand? Do you understand? Good. All right. So next thing, we're going to write down what they gave us. So they said 1 and 2 are supplementary. That's a sentence, not an equation. You can't write that they equal 180 and say it's given. They didn't give us that. Okay? They said it was supplementary. So let's write what they said. So angle 1, I'm going to do that in purple. Angle 2 in blue. These guys are supplementary. So angle 1, angle 2, sup. Also, just to stick with the theme, I'm going to skip the middle, and I'm going to go here. Angle 3 and 4 sup, right? Angle 3 is magenta or pink. It's closest I got. The other one's more of a mauve. And then 4 is the other angle, right? And they are sup. Cool. All right, so angle 1 and angle 4 are also given to us to be congruent, so I'm going to write that down. And that's all that's given to us. So I'm going to do the given, and let's do orange. So that's given. Cool. You might notice that since 1 and 4 are the same, they're interchangeable like right away, right? Like they're the same dumb crap, so they're substitutable. So what I'm going to do is I'm going to highlight those with brown to show that, hey, look, they're the same dumb crap whenever I see them, okay? This angle right here is congruent to this angle right here. That's given to us. Okay, so we have this information. What does it mean? What does it mean for those angles to be supplementary? Somebody. When you add them up, they sum to 180, right? Yes. So let's write that. So first thing we're going to write that isn't given to us is going to be measure. Remember, the measure is the amount that it is, the number, of angle 1 plus summed with the measure of angle 2. And I encourage you to get colors. It really helps for proofs, guys. It really does. Really does. $17 for a set of these pens. Okay, I know it's expensive, but they'll last you the whole year. Okay, they won't last me. Okay, but they'll last you, and that's going to add up to 180. Okay, now how do we know that? Well, remember we talked yesterday about the porn wars? Ban me, YouTube. Right? You don't need to be able to define everything in here. You don't need to be able to write out the definition. Words are hard, but you need to be able to know it when you see it. Supplementary. That's supplementary right there. I know when I see it. 2 angles add up to 180. Right? That's by definition. Okay, so by def. Now, by similar logic, if 1 and 2 equal 180 because they're supplementary, then shouldn't 3 and 4 also equal 180? So let's write that down. Measure of angle 3. Measure of angle 4. They're sup, which means they add up to 180, right? That's their sum. So this is good. What did this do for us? Well, first of all, we just knew it, so we wrote it down. Get in the habit of doing that. You don't know whether it's helpful or not. However, remember we need 2 and 3 in the same room, the same equation. We went from stuff that was not equations to stuff that was. That's a step in the right direction, right? That's good. Lots of ways to do this stuff, guys. The question is not where you end up, but where you're going, the direction you're moving in. And we're moving towards our goal. All right, so now we're here. And again, that's by definition, right? That's the definition of supplementary. We have an equation with 1 and 2 in it. Oh, man, we need 2 and 3 together. We have an equation with 3 and 4. Oh, man, we need 2 and 3 together. Not quite. What do these 2 equations have in common? At first glance, it doesn't look like much.
180.
180. A couple ways to do it. You could say, oh, look, 1 and 4 they have in common because they are the same. And that's one way of doing it. You could switch stuff out, substitute, do all that. It's a mess, but you can do it. Okay, I did it in another class because that's what they saw first. This is the second class that's seen the real key to save you a lot of time. Check it out. They both equal the same crap. So if 1 and 2 add up to 180, and 3 and 4 add up to 180, then 1 and 2 must add up to 3 and 4. Right? They equal each other.
Yeah.
If I told you x is 180 and y is 180, you know x equals y, right? That's it. So let's write that. They're the same dumb crap. So I'm going to write measure of angle 1. That's what I'm talking about, guys. Well done. Measure of angle 1 plus measure of angle 2. Equals, instead of 180, I'm going to substitute. I'm going to switch something out, right? Instead of writing 180, I'm going to write what 180 is. Measure of angle 3 plus measure of angle 4. And check it out. What do we have? We got everybody in the same room. There's a name for that. We call that by substitution, right? That's how we switched them out. SUBS, not SUBT, not SUB. That's not enough. SUBT is subtraction, right? SUB could be either. We need SUBS there at minimum, okay? So now everybody's in the same room. And again, if your goal was, okay, how do I get 2 and 3 together? How do I get 2 and 3 together? You might miss the point, right? It's not just 2 and 3. We can get other crap in there too. That's fine, right? You know, there's going to be other people at this party. The question is how we get some alone time now. Now we got them together in the same room. How do we get them alone, right? That way the magic can happen. Well, math is going to take care of that. So how do we get rid of the 1 and the 4?
Move them.
Move them. That's a good idea, right? But if I move them, they're just moving to the other side of the room. That's good, but we need them to go away. Math is all about making people and things go away. Subtract them. That's great. We move them by subtracting, but it's not going to go away. It's just going to move it over. You're right. You're absolutely right. You're on the right track. Moving it over is fine. You want to do that? Let's do that.
But you can first substitute.
Check it out. So she's doing something that you would have done next. She's going to do it first. I think it'll be easy for everybody to see, so I'm going to do it her way, but you're absolutely right. Okay? So here's what she's going to do. May noticed that 1 and 4 are the same dumb crap, right? They always have been. That's what they said at the beginning, right? So when I subtract them, shouldn't they cancel each other out?
Yeah.
Now, we can't just say that. We have to show it. So the way we're going to show it is we're going to switch one of these out for the other one. So I'm going to write, instead of measure of angle 1, I'm going to write measure of angle 4 here. That way when I subtract them, everybody and their mom's going to know they're going to go away, right? Angle 4 minus angle 4, that's 0, right? Every day. I don't even have to look back at here. So here's what I'm going to do. I'm going to substitute angle 1 for angle 4. Angle 3. Angle 2. Now we're here. And so now when I do what Justice was saying, right? When I subtract them, first that was by substitution, S-U-B-S, right? When I subtract them, those are going to go away, and that's when the magic happens. 2 and 3 are alone, right? And now we've proved that they have everything in common. Why are they not together? All right, so here we go. We subtract angle 4 from both sides, and we're left with this. Oh, no, I broke my color scheme. Oh, no. Totally fixed it. Autumn is not upset. Autumn, now that I know that you're a perfectionist, I feel like you're judging me constantly. Stop judging me, Autumn! How did I get rid of the 4s, Autumn?
Subtraction.
Gotcha. I understand. I didn't know that. Is it because of the 5? I can go back and draw it and erase it.
Oh my god.
Okay. By substitution. Or not substitution, subtraction. I got distracted. I got subtraction. Subtraction. And when you put distraction with subtraction together, you get subtraction. All right, so here we are. Now we're not done, because they wanted 2 on the left side and 3 on the right. Oh, we got that. But they wanted it congruent, not equal. Now we know if angles are equal, everything else is the same about them. That's what congruent means. Literally, they are the same thing in every way. So we get that for free. You just got to write it. Now, when we talk about equal sign, we're talking about numbers, right? That's the measure. When we're talking about congruent, we're talking about figures. So we're not talking about the measure. We're just talking about the figures themselves. And again, if you want to cheat, look at the top. Make it look just like that.
That's good.
Congruent sign, angle 3, swag box. We've been saving the red. There it is. Now, maybe you're lost because we did it, moment by moment. I had to switch pens a bunch. It seemed like a lot of work. Let me go back and run through play by play, okay? So here we are. Step 1 is I wrote down what we got. That is so important. Do it in color. Write it out so you don't have to go back up here. Just get it done. Not only is it important, but it's required, okay? We're going to be writing this out as paragraph style eventually. You got to tell me what we're given, okay? Next thing. And it's free points, right? So next thing. We've got 2 angles add up to 180. How did I know that? Well, they told us it was supplementary. So by definition, it is, right? I know it when I see it. Same thing here. 2 for the price of 1. Next thing. I combined them. How did I combine them? Well, I knew that if that equals 180 and that equals 180, they equal each other. That's substitution, right? Next thing, 1 and 4 are the same, so switch them out. That way when I subtract them, I get this, right? Game, set, match. How you feel? Deece? Haley, what's up?
Is it symmetric?
So symmetric property is when you flip them, right?
Yeah, I was just asking because I can't really see the
Oh, I'm sorry.
No, it's not there. It's just the cursive. I don't know what that's.
Okay, so these right here are subs, S-U-B-S, and that's subtraction with a T. Okay? Symmetric has the Y, and my Y's I draw like this.
Yeah, I was just saying. I didn't know how to. Can I use the proofs right here? It doesn't make. I thought you spelled it wrong.
Oh, I'm sorry. Yeah, and there it is, yes. Thanks for asking.
Can I switch?
Yes, you may. Good? Just stretching?
Me?
Yeah, you.
I'm taking my sweatshirt off.
Nice! All right, nobody watch. All right. Number 5, are you ready?
Okay.
Okay, so it says A, B, and C are collinear. So, first of all, we need to know what A, B, and C are. There they are. This does not have them written in. So I told you last time to write them in. This was A, I believe. B was the center point, the intersection of the two lines. And this was C. And then DBF because I skipped E, because E is for idiot. Okay, so that's what we're talking about. Now, why did they give us this? Why are we talking about collinear points? Because just because the diagram looks like they're lines doesn't mean they are. What if from B to A, it actually tilts a little, right? What if ABC isn't a line? What if it's just two little segments sticking off there, okay? So we need to know it's a line. So what I did is I told you those points are collinear. So we're given that. Let's write that down. Given ABC and DBF collinear. Right?
Can't see it.
Thank you very much. Appreciate it. So we're given that. Yeah, I had to adjust my camera now. I can't go off the tape. So tell me if I'm, not on the screen.
What is that? Is that a symbol?
That is an and symbol. It's ampersand. Yep.
Yeah, not and.
It's all right. It's all right.
Mr. Elbow.
Ampersand. All right. So if they're collinear, if those points are collinear, what do we know about the thing they lie on? It must be a line, right? So that's what we get. So again, using words, because these are collinear, the first thing I'm going to write is that ABF, right, that's symbol for line. It's goofy looking. ABC. Why did I do that? I've done that 2 classes in a row now. That's a C. Nope. And DBF are lines. Now, how do I know that? By definition. I know it when I see it, right? We got collinear points here. The only way it could be is lines. That's by definition. We have not officially defined what a line is in our notes because, at some point we have to assume something, right? And I assume that to save on space and ink. But it's by definition. I know it when I see it, okay? No yawning, Katie. It's math class.
I've been yawning this whole time.
Enough. All right, so we have that these are lines. Now, why is that important? Because while you might think, to prove that 1 and 3 are congruent, I could just use vertical angles theorem. Well, I told you last time you can't use that yet, okay? That'd be nice, right? You say they're vertical angles by definition, and then bam, vertical angles theorem says they're congruent. Done, right? Scissor theorem. Your words, not mine. We're not going to do that. What we're going to do is we're going to prove that these are congruent using the same method we used to prove vertical angles theorem to begin with. We're going to prove that 1 and 2 are a linear pair, and by linear pair theorem, therefore they add up to 180, right? And if they add up to 180, then we can say the same thing about 2 and 3. They add up to 180, don't they? Notice they share 2. And so that's going to be their common ground to get 1 and 3 together in the same room. That's the plan. So here's what we're going to do. We're going to say that angle 1. What color do you want angle 1 to be? Schlaffer, go.
Magenta.
Magenta. Angle 1 is magenta. So angle 1 and symbol, that's an ampersand. What is 2 going to be? What's it going to be? Make my day. Blue. We have 2 blues. Do you prefer dark blue or light blue?
I prefer the navy.
Light blue. In the Navy. All right, so that's 2. 1 and 2. What do we know about them? They're sitting on a line. How do we know it's a line? Because we just said it was a line. That's great, isn't it? So if they're both on a line, 2 angles on a line, what do we call them?
Collinear.
Something like that. Points are collinear. Angles. There's 2 of them, so it's a pair.
Supplementary.
We're going to get there.
Vertical.
2 angles that are on the same line. They're a pair.
What's it
Don't
start
you
with?
dare.
What's it start with?
Starts with an L. Ends with an linear.
Linear.
Linear pair. They're a linear pair by definition. Linear pair. Are a linear pair. How do we know that? Because they fit the definition. They're on a line and there's 2 of them. Linear pair by def. You with me? Thank you. All right. So 1 and 2 are linear pair by definition. Now, linear pair theorem says if we have a linear pair, what do we know about the linear pair? They equal 180. In fact, that's not the exact words. It just says they're supplementary. Remember, because we aren't always measuring in degrees, so we have an intermediate step. It's kind of annoying. So these add up to 180. We're going to say first that they're supplementary. Therefore, angle 1 and angle 2 are supplementary. They're sup. How do we know that? Bilinear pair theorem. It says if you have a linear pair, they're supplementary. That's the theorem. Okay? And we've proven that before because it's a theorem. So now we can use it. Now, you know that if something's supplementary from last problem, right? The last problem, what does that mean? They add up to 180, right? So the measure of angle 1 plus the measure of angle 2 is going to add up to 180. And now we're in something useful, right? We finally have an equation. And that's what we need. We need to get 1 and 3 together in an equation in the same room. Unfortunately, we just have 1 and 2 right now. So that is by definition, right? I'm able to say if they're supplementary, they add up to 180, because that's the definition of supplementary. Okay? Cool?
Cool.
So that's part 1. Now we're going to save some time. Here's the idea. We're going to do just like the last one. We need 2 equations that both equal 180. That way they can equal each other. Everybody's coming to the party, okay? So what I'm going to do is have 1 and 2 together and 2 and 3 together. Everybody's in the party, therefore 1 and 3 can be together at some point, right? That's the idea. So here's what I'm going to do to save time. By the same logic, this is your favorite phrase. By the same logic, the same way 1 and 2 are a linear pair, 2 and 3 are a linear pair. By the same way 1 and 2 are supplementary by linear pair theorem, right? 2 and 3 are going to be supplementary by linear pair theorem. By the same way that 1 and 2 add up to 180, because that's the definition of supplementary, 2 and 3 are going to add up to 180, because that's the definition of supplementary. So imagine 1 and 2 were replaced with 2 and 3. By the same logic is what that means, right? By the same logic, we must know that measure of angle 2, thank you, plus measure of angle 3, what color do we want 3 to be? Schlaffer, go.
Teal.
Teal, we already did teal.
Oh, yellow.
Yellow, wonderful. Orange was a great choice.
Yeah.
Measure of angle 3 equals 180. By the same logic, right? 2 and 3 are a linear pair. Linear pair theorem says they're supplementary. If they're supplementary, then they add up to 180. Okay? By the same logic. We love by the same logic. We didn't have to write all that again. That's glorious. Now, check it out. Remember last time? We've got 1 and 2 here and 2 and 3 down here. Oh, man, we want 1 and 3 in the same room. How can we get them together? What do they have in common? Well, they have 2 and 2 together. There's a way to manipulate that and do it with substitution in it. You got to move the thing over, and then you move that there. There's an easier way. What do they have in common? 180. See how they equal the same dumb crap, just like last time? Again, that's the simplest way of doing it. If you wanted to rearrange the equation where angle 2 is 180 minus 1, then you could replace that down there and then make some magic happen. It works the same way, okay? But I'm going to notice that these two equal each other. So I'm going to write that. Measure of angle 1 plus the measure of angle 2 equals not 180, but I'm going to replace that with angle 2 and angle 3.
Then you just subtract the
That's right. Rosie, smell when I'm stepping in. Pooping what you're swooping. And I did that by substitution, right? Didn't I switch out 180 for what it is?
Yeah.
Okay, so that's by subs. S-U-B-S. For the people in the back, right? Okay, so now we're here. We got 1 and 3 in the same room. That's great. That is worth so many points, okay? Because that's all you care about, the points, right? Even though they're made up and everything, doesn't matter, right? How do we get 1 and 3 some alone time? We got to do some math, yeah. Right, so we're going to do subtraction property, subtract 2 from both sides. Now, normally when we subtract 2 from both sides, it just moves it over, right? But because there's already a 2 there, when that becomes negative, we have a positive version and a negative version on the same side. They go away. They become 0, right? That's the magic. So by subtraction property, we're going to have angle 1 equals angle 3. The measure of both. And we did that by subtraction. S-U-B-T. And now 1 and 3 together, 1 on the left, 3 on the right. Well, we already have them left and right. That's good. We don't need to do symmetric property, right? We just need to rewrite it as the figures being congruent. So I'm going to write angle 1 is congruent to angle 3. We get that for free. We can put a little therefore symbol if you want to make yourself feel better. And we're done. Swag box. Boom. That's what they wanted.
We're not done.
We're done with that one.
That one, yeah.
Okay? I'm going to walk you through this because the next part is going to be very similar for 2 and 4. In fact, we're going to use the same by the same logic crap to save us a lot of time. So check it out. Let me walk you through it. Okay? We started out. ABC, DBF are collinear. There we go. They are collinear. They gave us that, which means that ABC and DBF are lines, right? By definition, right? If the points are all collinear, then the line itself is collinear. Next, 1 and 2 are a linear pair because they're both on the same line. Both meaning pair, 2, right? Line meaning linear pair, by definition, right? That's the definition of a linear pair. 1 and 2 are therefore supplementary because linear pair theorem says if you have a linear pair, they're always supplementary. What does it mean to be supplementary? They add up to 180, by definition. Same dumb crap, 2 and 3 are also a linear pair. Therefore, the linear pair theorem says they're supplementary, therefore they are added up to 180. They equal each other by substitution. I subtract from both, we're home free. Not so bad when we go through it in fast motion, right? Again, think of the concepts here. Don't think of the nitty-gritty. This is like when you make something in art and you've seen every single pencil or paintbrush stroke that you've done, right? Because you were there for it. You were there for its birth. And you saw it come into existence. Now, the person who just walks in and sees your art for the first time can't see that because all they see is the big picture, which is great because that's what you want. You see all the little imperfections because you made every single one of them. You were there for its birth. You know it intimately. But the person who's viewing your art only sees the big picture, which is why you hate your art and everybody else loves it. Don't get caught in the nitty-gritty, the little bits here. Think of the ideas, the concepts. Those are lines because they're collinear. Those are a linear pair because it's the definition. They're on a line. Those things are supplementary because linear pair theorem says if they're a linear pair, they must be supplementary. Supplementary means this. Same thing for this. They're equal to each other. Bam. That's the concept. It's not memorization. It's not PEMDAS. It's not straightforward. But that's terrifying but also beautiful. That's real math. You have freedom. Question?
Couldn't you save a bunch of time? I mean, I'm not trying to be smart.
No, it's cool.
But if you just said angle 1 and angle 3 are congruent because they're scissoring.
Yep, so that's exactly right. So I said you weren't allowed to use vertical angles theorem for this one. I didn't say it in the directions, but I said it the other day. But you're right. That does save us a lot of time, which is why theorems are useful, right? Once we've proven them, it takes all that away and we say 1 and 3 are congruent by vertical angles theorem. Done. First, we have to say that they're vertical angles, right, by definition. But then we're done, right? Great point. It's not being a smartass, it's being smart. Right? That's why people invented theorems. Well done. All right, so how do we prove 2 and 4? Well, the same dumb crap. 2 and 1 are a linear pair, therefore they equal 180. 1 and 4 are a linear pair, therefore they equal 180. Cut out the middleman, 2 and 4. So by the same logic, down here, by similar, I'll write similar logic to save time, we get that angle 4. What color is angle 4 going to be, Schlaffer?
Brown.
Brown. Good choice. Angle 4 is congruent to angle 2. And I'm going to write it the right way. Right, we need an angle 2 first. Done. Swag box. Okay, next thing we got to do. It says, then prove angle 1 and 2 are supplementary. Check this out, check this out, check this out. Have we done that somewhere?
No.
Oh, we're done. Look how easy that proof is. It's a little guy. Now, wouldn't we do the same thing when we do by the similar logic for 2 and 4? Right? Wouldn't we have to do that 1 and 2 are supplementary, right? We want to prove that 3 and 4 are supplementary. 1 and 4 are supplementary, 3 and 4 are supplementary, therefore, bam, 1 and 3 are the same, right? Yada, yada, yada. So if we would have done it during the similar logic phase, it's already done. Take a gander at that. Watch the video again in slow motion. Try to do these on your own. Come up with a different way to do it. See the connections. If you don't, you will be lost on Friday. I'll see you tomorrow.
Wouldn't it be
Yes,
nice
you may.
if we...
We're older, and we didn't have to wait so long. All right. Yep. No H, like my sister.
I'm ready to graduate.
Wouldn't it be nice?
That's right. There you go.
We're gonna play a song during game club today.
Who is Andrew Ramirez? I got comments from him.
I don't even know if Andrew Ramirez in the school.
I don't think we do. I think some of them do.
Maybe it's a terrorist. You better watch out. Your life could be in danger.